Hello students, my name is Santosh. Welcome to the GATE Academy Power Pack classes of Signals and Systems. So first of all, I'll introduce the agenda of this Power Pack classes. So in Power Pack classes, we are making 8 questions throughout the syllabus of the Signals and Systems. By watching these 8 questions, you will come to know what are the areas from where the GATE questions can be asked and how the questions are going to be asked. So this is going to be very useful for the students, especially the students who are going to write GATE 2019. So let us try to ensure that we are making most of this particular Power Pack classes. So let us start with the question number 1. So this question belongs to Introduction to Signals and Systems and from the topic of energy and power. Find the energy and power for the signals. First one, x of 1 minus t by 2. And second one is x of t plus 6. Third one is x of 2t plus 1 by 2. If x of t is, in the part A, x of t is equal to 2 for mod of t less than 1 and it is equal to 0 otherwise. The second part, x of t, the part B, x of t is equal to 2 cos 3t. In the third part, x of t is equal to u of t plus 1 plus r of t minus 1 minus 2 u of t minus 2 minus r of t minus 2. Okay, and the last part of the question is given as x of 2n plus 1. We have to find out x of 2n plus 1 and find the energy and power of this particular function x of 2n plus 1, where x of n is given as 1, 0, 3, 5, 2. So we have to find the energy and power of x of 2n plus 1. So this particular question focuses on one simple part, that what happens to the energy and power of any signal x of t when it is shifted, scaled and reversed. What happens to the energy and power of x of t when it is shifted, scaled and reversed. For example, if the signal x of t is having the energy E and the power as P, then what we know is that x of minus at plus B will have the energy as E by A and the power is going to remain the same. This is a very important point as far as the GATE exam is concerned, and the question has been asked before. So when the signal x of t is having the energy E and power P, then x of minus at plus B. What is minus at plus B? B indicates the shifting, minus indicates the reversal, and A is going to indicate what? Scaling. A is going to indicate the scaling. So energy is only affected by scaling. The energy is only affected by scaling and the power is not affected even by scaling. Energy is only affected by scaling, whereas power is not at all affected by shifting, scaling and reversal. This point is important to solve this question. In the very first part of the question, x of t is equal to 2. X of t is equal to 2 for the mod of t less than 1 and it is equal to 0 otherwise. And this question is an energy signal. Why? Because we learn in the class that energy signal will have 2 categories. First one is that it will be bounded and finite duration. And this belongs to bounded and finite duration. And also you can have a signal which is an energy signal which is bounded, infinite duration with decaying amplitude. These are the 2 characteristics that you can have, either have in the case of the energy signal. So whenever we are talking about the energy signal, energy will be finite and power is going to be equal to 0. When we talk about power, we are actually referring to the average power of the signal. When we are talking about the power, we are actually referring to the average power of the signal. So therefore, I can look at the question and tell it's going to be an energy signal and power will be equal to 0. Now let me find out what is the energy of this particular signal. Graphical representation of the signal is that it's going to be equal to 1, it's going to be equal to 2 between t minus 1 and 1. So let me find the energy because it's a real valued signal. Integral minus infinity infinity x square of t dt. In a general formula you will have a mod also. Mod of x of t whole square dt. But mod is applicable or required only in the complex valued signal. In the case of real valued signal, there is no significance of keeping a mod. So x of t square, and we know the signal is only between minus 1 and 1. In the rest part it's going to be 0. So therefore I will take it from minus 1 to 1. The value of the signal is 2 square dt. So it means that it's going to be 4 into 2, which is 8 joules. It's going to be equal to 8 joules. This is the energy of the signal, which is going to be 8 joules. If the energy is finite, then the power is going to be equal to 0. It's not even required to solve the problem. The power is going to be equal to the top 0. So energy is finite and power is going to be equal to 0. This is for the signal x of t. So if this is the case, then the part is a part 1. Part 1 is that we have to find the energy and power of x of 1 minus t by 2. What is the scaling parameter? Energy is only affected by the scaling parameter. So what is the scaling parameter in this case? 1 is indicating the shifting, minus indicates the reversal, and 1 by 2 is indicating the scaling parameter. So after scaling, the energy is going to become E by 1 by 2. So therefore, which is E in this case is 8 by 1 by 2 is going to be equal to the top 16 joules. Second part of the question is that we have to find for x of t plus 6. X of t plus 6. The energy is going to remain the same, which is going to be 8 joules, and power is going to remain the same, which is 0 watts. So x of t plus 6, because it is having a scaling parameter of 1, it means that there is no scaling that you are doing. So therefore the energy is going to remain the same, whereas the power is going to be 0. Third part of the question, we have to find the energy and power of x of 2t plus 1 by 2. We have to find the energy and power of x of 2t plus 1 by 2. Here the scaling parameter is 2 and the shifting parameter is 1 by 2. It doesn't matter what the shifting parameter is. The scaling parameter is important for us. Why? The energy is going to become E by 2 and the power is going to remain the same. So E by 2, it means that 8 by 2 joules and power is going to remain 0 watts. So this is for the part A. So in the part A, the first part is x of 1 minus t by 2, which is having the energy of 16 joules and power is 0. Here in the second part, you are having energy as 8 joules and power is 0. Third part, it's going to be 4 joules and the power is going to be 0. Right? So now let us go for the second part. What is the second part given as? The part B. So the part B, here is going to be a sinusoidal function. So sinusoidal function, which is x of t is equal to 2 cos 3t. Right? So the part B is given as x of t is equal to 2 cos 3t. X of t is equal to 2 cos 3t. It's a sinusoidal function. And we know whenever we are having a bounded periodic function, it is always going to be a power signal. It is always going to be a power signal. And the energy of the power signal is going to be infinity. So nothing to find out about the energy. Energy is going to remain infinity. What about the power? Power is going to be finite. And this is a sinusoidal function. And when it is a sinusoidal function, I can have a square by 2, where a is the amplitude of the signal. So therefore it's going to be what? 4 by 2, which is 2 watts. So the energy is infinity and the power is going to be equal to the top 2 watts. This is in the case of a signal x of t. Right? What about x of, the first one is 1 minus t by 2. Energy is going to remain the same, infinity, because infinity by 1 by 2 is going to be infinity only. And the power is going to be 2 watts. The second part of the question is x of t plus 6. Same. And the third part of the question is x of 2t plus 1 by 2. It is also going to have the energy and power. Energy is going to be infinity only and the power is going to be 2 watts. The power is not affected by the shifting, scaling and reversal. The third part. What is the third part? C. And C here is nothing but x of t is equal to u of t plus 1. U of t plus 1 plus r of t minus 1 minus 2 into u of t minus 2 minus r of t minus 2. This model is also very important in the examination point of view. Given a question in terms of the step and drive information, we have to have a graphical representation of it. After the graphical representation, we can do the energy and power. So first of all, I will do the graphical representation of the signal. Please look at the board carefully. Graphical representation of the signal. First of all, you are starting with t is equal to minus 1. We were starting with t is equal to minus 1. at t is equal to -1, you are having a step of 1 unit. You are having the step of 1 unit. It means that there is a sudden increase in the amplitude of 1 unit. There is a sudden increase in the amplitude of 1 unit, and it is going to go with the same amplitude. It will go with the same amplitude until you are adding anything else. At t is equal to 1, you are adding a ramp function. R of t minus 1 indicates that there is a ramp at t is equal to 1. R of t minus 1 indicates that there is a ramp at t is equal to 1. So you are adding a ramp at t is equal to 1 and with a slope of 1 unit. And with a slope of 1 unit. Before that there is no slope. The slope is equal to 0. And now you are adding a slope of 1 unit. It means that there is a sudden increase in the value of slope, which is 1 unit. Right? So it will go with the same ramp until you are adding anything. And what you are adding at t is equal to 2, you are adding a ramp of t. You are adding a ramp of -1. You are adding a ramp of -1 to already existing ramp of 1 unit. To already existing ramp of 1 unit. So what happens to the slope now? The slope is now going to become equal to 0. Now, not only that, you are adding a step of -2. You are adding a step of -2. What is the amplitude here? Here the slope is 1. You are moving 1 unit. It means that here also you are gaining 1 unit. So it becomes 2. Now you are adding a step of -2 to already having amplitude of 2. To already existing amplitude of 2, you are adding a step of -2. It means that now the amplitude becomes 0, and you can also see that the slope is also 0. Why the slope is 0? Because you are adding a slope of -1 unit. Because you are adding a slope of -1 unit to already existing 1. To already existing 1, you are adding -1. So now the slope becomes 0 and amplitude also becomes 0 for the fact that you are adding an amplitude of -2 units. You are adding a slope, amplitude of -2 units to already existing 2. So 2 minus 2, there will be a sudden fall in the amplitude of 2 units. So now the amplitude also becomes equal to 0. So the graph is going to be something like this. The graph is going to be something like this. So if I want to represent this particular in terms of mathematical, x of t is equal to 1 for the value of t between -1 to 1, and it is equal to t because you can see as you extend this line, it's going to be equal to 0 only. So x of t is equal to t for the value of t between 1 and 2, isn't it? Y is equal to mx plus c. Y is equal to mx plus c. This is how you write a line. Here y is nothing but the function x of t. Yes or no? X of t, what is the slope? Slope here is going to be 1 unit. X is nothing but t. And c is something that we don't know. We can find the c. X of 1 is equal to 1, which is equal to t is equal to 1 plus c. So the value of c is equal to 0. So it means that the c value is equal to 0, x of t is equal to t. That is how I wrote it. X of t is equal to t for the t between 1 and 2. X of t is equal to t for the t between 1 and 2. And it is equal to 0 otherwise. It is equal to 0 otherwise. So this is the mathematical representation of a signal. This is a mathematical representation of the signal x of t. Now let us find the energy and power for the signal. Let us find the energy and power for the signal. Can you please tell me whether it is an energy signal or a power signal? Which type of signal are we discussing here? Is it an energy signal or a power signal? Is it an energy signal or a power signal? This is clearly an energy signal. This is clearly an energy signal. Why? It is having only a finite duration and bounded in amplitude. It is bounded in amplitude and finite in duration. So whenever any signal is going to be bounded in amplitude and finite in duration, it will clearly be an energy signal. It will clearly be an energy signal. So in any energy signal, the average power value is going to be equal to the of 0. So let us find the energy first of all. So the energy of the signal is given by integral minus infinity to infinity x square of t dt in the case of a real valued signal. If it's a complex valued signal, we will add a mod also. So mod of x of t whole square dt. So now we know from -1 to 1, you are having the amplitude value of the signal is 1 square dt, and from 1 to 2, you are having the x of t is nothing but t square dt. So therefore, here you are going to have 1 multiplied by 2 plus t power 3 by 3 from 1 to 2. So it is 2 units here plus 8 minus 1, which is 7 by 3. 8 minus 1 which is 7 by 3. So it is going to be 13 by 3 joules. It's going to be 13 by 3 joules. The energy of the signal is going to be equal to that of 13 by 3 joules. So if the energy is going to be 13 by 3, the power is going to be 0 watts. So you have to keep in mind that whenever the energy value is finite, the power value is always going to be equal to that of 0. Okay, so we found out the energy and power in the case of the signal x of t which is given. Now what we have to do? We have to find the energy and power of the signal, the three parts which are given. The first part is that we have to find for x of 1 minus t by 2. 1 minus t by 2. What is the energy for this one? If the energy of x of t is E, it's going to be E by A. Scaling parameter here is 1 by 2. So which is 2E. What is the energy? Energy is 13 by 3. So if the energy is 13 by 3, 2E is going to be 26 by 3. Energy here is going to be 26 by 3 and the power is going to be equal to 0 watts. The second one is x of t plus 6. The energy is going to remain the same, which is 13 by 3 joules, and the power of the signal is going to be 0 watts. The third one is x of 2t plus 2. 2t plus 2 signal will have the energy is equal to that of E by 2, which is going to be 13 by 6 joules, and the power is going to be still 0 watts. So with this we complete the third part, which is C. Now coming to the last part of the signal. What is the last part? It's a discrete time signal. X of 2n plus 1 is what we have to find, where x of n is given to be 1, 0, 3, 5, 2, where at the 2 you are going to have an arrow. At the 2 we are going to have an arrow. So x of n is equal to 1, 0, 3, 5, 2. We have to find the energy and power of x of 2n plus 1. We have to find the energy and power of x of 2n plus 1. So here we are not going to use this particular formula that we have used for continuous time signals. So here we are going to do the first of all shifting and then the scaling. So let us shift it. X of n plus 1 advancing by 1 unit. Whenever I advance by 1 unit, I am going to shift the arrow towards right by 1 unit. Whenever I advance the signal by 1 unit, I am going to shift the arrow towards right by 1 unit. So it is going to become 1, 0, 3, 5, 2 and 0. This is my x of n plus 1. From x of n plus 1, I will apply the scaling so that it's going to become x of 2n plus 1. So what is x of 2n plus 1? X of 2n plus 1 is going to be 0. So whenever I am going to do where the scaling parameter is greater than 1, here the scaling parameter is 2. So I am going to do the downsampling. I am going to reduce the number of samples I am going to have in the original signal. So whenever I do the downsampling, when the scaling parameter is 2, I am going to pick every second sample. I am going to pick every second sample. I am going to discard the remaining samples. I am going to pick every second sample. So what I am going to have 0, 5 and then 0. Right? So x of 2n plus 1 is going to be 0, 5 and 0. This is nothing but x of 2n plus 1. Now we have to find the energy of this. Energy is nothing but summation of x of 2n plus 1 square, where the value of n changes from minus infinity to infinity. So you are having only one sample, which is 5. So 5 square, which is equal to 25. So whenever the energy is finite, the power is going to be equal to the of 0. So 25 joules is the energy of the signal and the power is going to be equal to the of 0. So with this we complete the first question. So before going to the second question, I will just let you know that the major problem that the students face in the case of signals and systems is nothing but the shifting, scaling and reversal. So there is a confusion which is inbuilt there in the shifting, scaling and reversal. As you do more number of problems, you will get the clarity. I am talking about the case where you want to shift, scale and reverse all the signals. And you know that whenever you are going to do shift and then scale and then reversal, there generally will not be any problem. But whenever you do the shifting or reversal before that whenever you do the shifting, whenever you do the scaling and reversal before shifting, then there will be a problem. So I request all of you to ensure that you have the clarity while doing the shifting, scaling and reversal, especially when you are doing the scaling or reversal or both before the shifting operation. Samajh mein aa raha hai? Is it clear? Whenever you are doing the shifting after scaling or reversal, you have to be very careful. So with this we complete the first part of the question. Now let us go for the second question. And this is based on the system properties. Right? So let me read the question. Check whether the following systems are linear, time invariant, causal, stable and invertible. So we have to look at the 5 properties: linearity, time invariance, causal, stable and invertible. The first part of the question is given as A, which is y of t is equal to 5x of t plus 2. So y of t is equal to 5 into x of t plus 2. Y of t is equal to 5 into x of t plus 2. So here we wanted to say about the linearity. So linearity means we will always check the superposition principle. We always check the superposition principle. In the examination property, it's simple to say if the x of t is going to have the output as y of t, then it is sufficient to check the scaling property, which is a into x of t is going to be a into y of t. If this thing is satisfied, then we can directly say that the system is going to be linear in nature. The system is going to be linear in nature. But this thing is something that we have already seen in the class. Okay, in the classroom, this is a very important question that we will look at. Y is equal to scaled part of the signal 5 into x of t plus 2, amplitude shifting. So whenever you are doing this amplitude shifting, whenever you are adding some value of a constant to any x of t, it's going to be always non-linear in nature. What I'm saying here is that whenever you are trying to add any DC component to the signal, it will always be non-linear in nature. For example, if I have y of t is equal to 5x of t, you can clearly see there is a linear relation between y of t and x of t. This will be linear. But y of t is equal to 5 into x of t plus 2. This is going to be non-linear. And this question has already been asked many times in GATE in different forms. Even in GATE 2018, the question has been asked on it. Y of t is equal to 5 into x of t plus 2. Whenever you are adding a DC component, it means that when you put the value of x of t is equal to 0, your output is non-zero. Whenever your output is non-zero, when x of t is 0, that system is always non-linear in nature. That system is always non-linear in nature. So for that particular reason, this particular system represents a non-linear system. Why? Because the output y of t is non-zero. Output y of t is non-zero when x of t is 0, when the input x of t is 0. For that reason, we are declaring the system to be a non-linear system. Coming to the time invariance, definitely this particular system satisfies time invariance. Time invariance will be satisfied because of the fact that unless and until you are having the case of t into f of t, f of t into x of t, or x of at, x of minus t. If your output y of t is in this particular form, then it is going to indicate that the system is going to be a time variant system. But here we are not doing any time variant operation. We are not doing any time variant operation. So the actual process of checking it is that first of all we will find out y of t minus t1. First of all we will find out y of t minus t1. And what is our aim? Our aim is that if you are having a system x of t for which the output is y of t, x of t minus t1 has to lead to the output y of t minus t1. This is our aim. Our aim is that when x of t is given, the output is y of t, x of t minus t1 has to lead to y of t minus t1. If it does not lead, it's going to be a time variant system. Otherwise, it's a time invariant system. Time invariant simply means that the behavior of the system should not change with time. The behavior of the system should not change with time. So first of all, I will compute y of t minus t1. What is y of t minus t1? 5 into x of t minus t1. 5 into x of t minus t1 plus 2. Then the process is that I will take, let x of t minus t1 be some function of x1 of t. Be some function of t, which is x1 of t. If I give x1 of t as the input, the output of the system is going to be y1 of t. If I give x1 of t as the input, then the output is going to be y1 of t. If y1 of t is going to be equal to y of t minus t1, then only the system is a time invariant system. So what I did here, first of all, I found out what is y of t minus t1. I found out what is y of t minus t1, and the second step is that I have assumed that my x of t minus t1 as another function of time x1 of t. If I give x1 of t as the input to the same system, then the output should be y1 of t. If y1 of t is equal to y of t minus t1, then the system is declared to be a time invariant system. System is declared to be a time invariant system. So therefore, what is y1 of t? System's operation is something that you have to keep in your mind. The system, what it is doing is that it is multiplying your input by 5 and then it is adding 2. It is multiplying the input by 5 and then it is adding 2. So if you give the input as x1 of t, the input is going to be multiplied by 5 and then it is going to add 2 to it. The input is going to be multiplied by 5 and then it is going to add 2 to it. So if that is the case, your y1 of t is going to be 5, x1 of t is nothing but x of t minus t1 plus 2. So therefore, which is nothing but y of t minus t1, time invariant operation. So if you are having a sufficient amount of practice, you can just look at the question and tell whether it's a time invariant system or a time variant system. And major thing is that whenever you are having a time variant system, you will always have these properties. What is that? Y of t is equal to f of t multiplied by x of t. Y of t is equal to x of at. Y of t is equal to x of minus t. These are the three important things which indicate the time variance. These are the three important things that indicate the time variance. So whenever you are doing a scaling operation on time, it's going to indicate the time variance. Whenever you are applying the time reversal, it is also a time variant operation. Or if you are multiplying your input x of t with some function of time, it is also going to be a time variant system. It's going to be a time variant system. But important note here is that this f of t cannot be a function of x of t function. This f of t function cannot be a function of x of t function. It should not be a function of x of t function. So these are three important things which indicate the time variance. So in this case, we are not doing a time variant operation. Why? Because your output y of t is going to be 5 into x of t plus 2. 5 into x of t plus 2. So this is not at all, nowhere you are doing the time variant operation. Nowhere you are doing a time variant operation. And your result also implies the same thing. So linearity is over, time invariance is over. Third one is going to be a causal operation. What is a causal? When do we say that a particular system is going to be causal? When do we say a particular system is going to be causal? A system is said to be causal. A system is said to be causal only when if the output of the system depends upon the present and past but not on the future values of the input. If the output of the system depends on present and past but not on the future input, it doesn't depend upon the future input. So current system y of t is equal to x of t plus 2 that you are having. The current system y of t is equal to 5 into x of t plus 2 you are having is clearly a causal system. Why? Because you are having dependency only on the x of t, which is the present input. If I take an instant of 5, the output at t is equal to 5 is going to be 5 times that of the input at t is equal to 5 plus 2, which indicates that even this particular system doesn't require any memory. Okay, so it has to be a causal system. The moment the output does not depend upon the future value of input, the moment your output doesn't depend upon the future value of the input, such a system is always going to be a causal system. Whenever your system is not depending on the future value of the input, that is always going to be a causal system. By that logic, it is going to be a causal system. Fourth one is the stability. Fourth one is the stability. So how do we check the stability? How do we check the stability of the system? The stability of the system is checked by considering that for every bounded input, the output is going to be bounded. For every bounded input. It is not that if you are having 10 inputs, 9 of them are bounded and you are checking that the output is going to be bounded in nature. I'll explain this once again. The fourth one is about the stability of the system. So how do we say the system is going to be stable? A system is said to be stable when for every bounded input, the output is going to be bounded in nature. For every bounded input, the output is going to be bounded in nature. For example, if you are having 99 bounded inputs for which the outputs are bounded in nature, but for the 100th bounded input, the output is unbounded in nature, still we will call that particular system to be a stable system. Still we will call that particular output to mean the system to be a stable. I'll do it once again. Stability of the system, the fourth one. What is the condition for stability of the system? System is said to be stable if for each and every bounded input, the output is bounded in nature. If for each and every bounded input, the output is bounded in nature. So whenever this is satisfied, we will call the system to be a stable system. Let us take an example. For example, I am having 100 bounded inputs which I am going to give to the system to see whether the output is going to be bounded or not. For example, for all the 99 bounded inputs, I have observed that the output is going to be bounded in nature. But for the 100th bounded input, I have seen that the output is unbounded. Am I going to call it as a bounded system? Am I going to call it as a stable system or an unstable system? What am I going to call the system as? The system will be called as a unstable system. The system is going to be called as a unstable system. Why? For a system to be stable, for each and every bounded input, the output has to be bounded in nature. I am going to apply each and every, even though for 99 bounded inputs, the output is bounded, but for the 100th bounded input, it is not bounded. So therefore, I will call this particular system to be a unstable system. I will call this particular system to be a unstable system. So, but this particular system is going to be a unstable system. Let us check this. So, x of t and y of t. So, x of t, let me give any bounded input. Let me call the output, bounded input is 5. So, what is the output going to be? 5 into 5 plus 2, which is going to be 27. So, let us take the second bounded input as 10. So, 5 into 10 plus 2, which is going to be 52. So, you will observe that, is there any bounded input for which the output is unbounded? Is there any bounded input for which the output is unbounded? You will observe that you are not going to have any bounded input for which the output is going to be unbounded. For all the bounded inputs, whatever bounded input you are going to apply, for each and every bounded input, the output is equally going to be bounded in nature. It can be having a bigger value, but still the value is going to be bounded. Bounded means finite amplitude. Bounded means finite amplitude. So for each and every bounded input, the output is going to be bounded in nature. So therefore, we will call this particular system to be a stable system. And the last property, fifth property is the invertibility of the system. How can we say a particular system is going to be invertible? How do we say a particular system is going to be invertible? A system is said to be invertible. A system is said to be invertible if the output, if the input can be retrieved from the output. If the input can be retrieved from the output, such a system is what we call as a invertible system. Such a system is what we call as a invertible system. So in the examination point of view, to check the invertibility of the system, what we see is that we will follow particular rule that invertible system generally has. The rule is that for every distinct input, the output has to be distinct. For every distinct input, it should lead to the distinct output. It should lead to the distinct output. For each and every distinct input, the output should be equally distinct in nature. The output should be equally distinct in nature. Such a system is what we call as a invertible system. Here you can check for any distinct inputs, x of t and y of t. Say in the examination point of view, we will always look for two different inputs for which the output is going to be same. Two distinct inputs for which the output is going to be same. Is it possible in this case? Let me try. Let me take the value of x of t to be 4. What is the output going to be? 5 into 4 plus 2, which is 22. Let me take minus 4. 5 into minus 4 plus 2, which is going to be minus 18. You will observe that for different inputs, for distinct inputs, the outputs are going to be distinct in nature. For distinct inputs, the output is going to be distinct in nature. So therefore, I will call this particular system is going to be a invertible system. This particular system is going to be a invertible system. Is it clear? Let us do one more problem, but this time on the discrete time function. So let me consider that output y of n is going to be x of minus 2n. Output y of n is going to be x of minus 2n. And we have to check the linearity and time invariance, causal, stable, invertible. We have to look at all the properties. Y of n is equal to x of minus 2n. Y of n is equal to x of minus 2n. First, we will start with the linearity. Linear system means x of t gives y of t. Here it's a discrete time. X of n gives y of n. So in the case of a linear system, the x of n has to lead to y of n. Then a into x of n. A into x of n has to give me a into y of n. If this is satisfied, then I will call my system to be a linear system. If this is satisfied, I will call my system to be a linear system. So let me check. X of n gives me the output. When I pass through my input, when I pass through the system, it's going to give me the output to be x of minus 2n. Sahi baat hai? It's going to give me the output y of n is going to be x of minus 2n. So if I do the scaling, a into x of n, what it is going to give me? The scaled part of, correct or not? Is this a into y of n? A into y of n? Yes, of course. So therefore, this particular system is going to be a linear system. It satisfies the superposition principle. Second one is the time invariance. Second one is the time invariance. I already discussed with you that whenever the output y of n is going to be something like x of an, it is going to be a time variant system. It's going to be a time variant system. So second one is going to be a time variant system. Third one, it is about the causality of the system. It's about the causality of the system. So how can we say a system is going to be causal? It depends upon, it can depend upon present and past, but it should not depend upon the future value of the input. It should not depend on the future value of the input. So therefore, let us see whether it is going to depend on the future value or not. So if I take the value of n is equal to minus 2. If I take the instant of n is equal to minus 2, then output at n equal to minus 2 is going to be x of 2n. It's going to be x of minus 2. If I keep here, it's going to be 4. Okay, I'll do this once again. Now let us look at the causality of the system. Third one, causality of the system. So y of n is equal to x of minus 2n. So if I take the value of n is equal to minus 2, let us say, let the value of n is equal to minus 2. Then what happens? Y of minus 2 is going to be equal to the of x of 4. Y of minus 2 is equal to the of x of 4. What does it mean? Y of minus 2 is equal to x of 4. The instant of n is equal to minus 2, it depends upon the future value of the input. It depends upon the future value of the input. It depends upon the future value of the input. It means that it is going to be a non-causal system. It's going to be a, it is going to be what? Non-causal system. So the causality property is going to fail here. Next one about stability. See, if you are doing only time scaling and time reversal operations, the system is going to be stable only. The system is going to be stable only. So it is going to be stable system. If you are purely doing only the reversal and shift and scaling, if you are only doing the reversal and scaling, in fact, if you are doing all the three operations, x of at plus b, x of minus a n plus b, it means that you are doing the shifting, scaling and reversal. Still the system is going to be stable. Still the system is going to be stable. So it is a stable system. What next? We have to look at the invertibility of the system. We have to look at the invertibility of the system. The system is going to be invertible. The system is going to be invertible because we know if you do the operation, if you are having x of n as the input, the output is x of minus 2n. The operation that you are performing here, the system, what it performs here is that n becomes minus 2n. Now, if I do the opposite operation, ultimately I have to get back my input. If I do the operation, that n becomes minus n by 2. If n becomes minus n by 2, then what am I having? Then I'm having the overall output is going to be my input itself. That is the invertible system. So if the input can be retrieved back from the output, if the input can be retrieved back from the output, such a system can be called as a invertible system. So what I'm doing here, your system that is given here is that your output is going to be x of minus 2n. So on x of n, it is doing the reversal and scaling of 2 units, and you are getting the output to be x of minus 2n. And what you are doing now, in order to get the input back, I am doing the scaling of 1 by 2 units with a reversal. Right. So therefore it is going to be invertible. So in fact, if you are doing shifting, scaling and reversal operations, they are also going to be invertible operations. Shifting, scaling and reversal are also going to be invertible operations. So first it is linear, second it is time variant, third it is non-causal, fourth it is stable, and fifth one it is a invertible system. So with this we complete the second question. Now let us discuss about the third question. The third question is from the chapter of LTI systems. It is from the chapter of LTI systems, where we will majorly discuss about the concept of convolution. So in this question, we are having a signal which is x of t is equal to 2. We are having a signal x of t is equal to 2 for t between 0 to 2. For t between 0 to 2, and it is 0 otherwise. And it is 0 otherwise. Then what we have to do? We have to draw the following signals. First one is that we have to draw this particular signal x of t convolved with the of x of 2t plus 1. X of t convolved with the of x of 2t plus 1. So we are having a signal which is 2 for the value of t between 0 and 2, and it is equal to 0 otherwise. So it's an example of a rectangular pulse. It's an example of a rectangular pulse. So the signal x of t which is given to me is an example of a rectangular pulse 0 to 2. It's going to be 2 units. Now I am convolving x of t with what? I am convolving x of t with it of x of 2t plus 1. I am convolving it with it of x of 2t plus 1. So 2t plus 1 means I am going to do the shifting first. And the shifting is an advancing operation. So I am going to advance the signal by 1 unit. And then t becomes 2t. It means I am scaling it by 2 units. So if I scale by 2 units, so I am scaling it by 2 units. You know that how to do the scaling. So whenever I am doing the scaling of a units or t 2 units here, I am going to divide my actual time axis by the scaling parameter. I am going to divide my actual time axis by the scaling parameter. So here we go. We are having a time scaled and shifted signal, which is x of 2t plus 1. Now what we are going to do? We are going to convolve these two signals. So we have observed one property when we are discussing in the class. What is that? Whenever we are convolving two rectangular pulses, first case is that when they are having equal width. So whenever your signals are having equal width, then what is going to happen? It is going to lead to a triangular pulse. It's going to lead to a triangular pulse. So when they are of unequal widths, then it's going to lead to a trapezoidal pulse. So whenever you are having two rectangular pulses of unequal amplitude, here is the case of unequal amplitude. Here we are having width of 2 units and here we are having a width of 1 unit. So it is a case of unequal amplitudes. So whenever we are having unequal amplitudes, then the resultant will always be a trapezoidal pulse. It means that it's going to be equal to what? It's going to be a trapezoidal pulse. What is the lower limit? Lower limit is the summation of the lower limits. Lower limit is the summation of lower limits. So it's going to be minus 1 by 2 itself. And it's going to have a raising arm. Trapezoidal pulse, it will have a raising arm, constant amplitude region, and it's going to have a falling arm. So raising arm will have the duration of the smaller rectangular pulse. Raising arm will have the duration of a smaller rectangular pulse. So it's going to be something like this, till 1 by 2. And the constant amplitude region, this part is going to have a width of difference of the rectangular pulse widths. Here it is 2 units, here it is 1 unit. 2 minus 1, it's going to be 1 unit. So for 1 unit, you're going to have a constant amplitude region. It means here it is 3 by 2. And for 1 more unit, you're going to have the falling region. So 5 by 2. So raising arm and falling arm will have the same duration, which is equal to the width of the smaller rectangular pulse, So therefore it is going to be 1 unit here and 1 unit here. Here also it's going to be 1 unit because of the fact that the difference between the widths of the rectangular pulses is also going to be 1 unit. The difference between the widths of the rectangular pulses is also going to be 1 unit. So therefore it is also going to be 1 unit here. What about the slope here? The slope of raising arm is equal to the slope of falling arm, and it is equal to the product of the amplitudes. And it's going to be the product of the amplitudes. Here it is 2 units. Here also it is 2 units. So the product is going to be 4 units. So the width, the slope of the raising arm will be equal to the slope of the falling arm. Falling arm means always the slope is going to be negative. Okay, so the magnitude of the slope is going to be 4, but for rising arm it's going to be plus 4, and for the falling arm it's going to be minus 4. So for 1 unit, if you are having a slope of 4, the amplitude is also 4 units. So this is the result of convolving the signals x of t and x of 2t plus 1. This is the result of convolving two signals x of t and x of 2t plus 1. Is it clear? Now let us go for the next question. So the B part of the question is that we have to convolve x of t with it of d by dt of x of t. X of t plus 1, I'm sorry. I think we already have an x of t plus 1. So we are going to differentiate it. Okay, so x of t plus 1 in terms of step functions is going to be what? In terms of step functions, it's going to be, you're having positive step here and a falling step here. So positive step at t is equal to minus 1. So I can write it as u of t plus 1. And a falling step at t is equal to 1. So I can write it as u of t minus 1. So rising step and falling step. A rising step is present at t is equal to minus 1. And the falling step is present at t is equal to 1. So u of t plus 1 and u of t minus 1. So how many units here? 2 units. And here it's going to be minus 2 units. So rising step of 2 units and falling step of minus 2 units. Now differentiation of this. D by dt of x of t plus 1. D by dt of x of t plus 1 is going to be what? The differentiation of step is going to be a delta function. Differentiation of step is going to be a delta function. Here also. So basically you are having 2 delta functions. One at t is equal to minus 1. With the area of 2. The coefficient of delta is always going to be the area. And here it's going to be minus 2. That t is equal to 1. So whenever we are convolving these two functions, so x of t convolved with it of this function, which is 2 times it of del of t plus 1 minus 2 times it of del of t minus 1. Here comes a very important property. Whenever you are convolving any signal with enough impulse, whenever you are convolving any signal with enough impulse, it is going to be a signal itself. Whenever you are convolving any signal with an impulse, it's going to be a signal impulse. The signal itself. So therefore, x of t convolved with it of 2 times it of del of t plus 1 is going to be what? 2 times it of x of t plus 1. You are using the time shifting property also. So whenever you are having any shifts here, the same shift will be there in the output also. Same here, x of t convolved with it of del of t minus 1 is going to be x of t minus 1. If you are only having x of t, let us say, if you are only having x of t convolved with del of t is going to be x of t. X of t convolved with del of t is going to be x of t. Because you are having shift here, there will also be the shift in the output. Okay, here we are using the property that if x of t convolved with h of t, if it is y of t, then x of t convolved, x of t minus t1 convolved with h of t minus t2, h of t minus t2 will be equal to y of t, the summation of total shift, which is minus t1 minus t2, y of t minus t1 minus t2. So right, so ultimately the convolution of these two functions is going to be what? 2 into x of t plus 1 minus 2 into x of t minus 1. What we have to do here is we have to do the pictorial representation of the scene. Okay, we have written it mathematically, but we have to have a pictorial representation. We already have x of t plus 1. What is x of t plus 1? It's going to be minus 1 to 1 x of t. Now what you should have? This is x of t plus 1. X of t minus 1 is nothing but the delay which is happening on x of t. If I delay the function, generally what you are having? Generally you are having 0 to 2. So when I delay it by 1 unit, what happens? It will be from 1 to 3. It will be from 1 to 3. It means that from 1 to 3. And the amplitude is going to be 2 units each. Here it is going to be 2 units, and here also it's going to be 2 units. So x of t plus 1, 2 into x of t plus 1 minus 2 into x of t minus 1. So if I multiply x of t plus 1 with 2, if I multiply x of t plus 1 with 2, here it becomes 2 into 2, which is 4. Here also multiplied by 2, 2 into 2 it's going to be 4. Right, so therefore what happens if I subtract it? X of 2 into x of t plus 1 minus 2 into x of t minus 1. 2 into x of t plus 1 minus 2 into x of t minus 1 is nothing but 4 minus 0 between minus 1 to 1. Between minus 1 to 1, you are having 4 units. And from 1 to 3, here it is 0 and here it is 4. 0 minus 4, it's going to be minus 4. 0 minus 4, it's going to be minus 4 from 1 to 3. So from minus 1 to 1, you are having 4, and from 1 to 3, you are having minus 4. So this is your resultant signal, which is 2 into x of t plus 1 minus 2 into x of t minus 1, which is nothing but the convolution of x of t with of differentiation of x of t plus 1. X of t with of differentiation of x of t plus 1. So we have completed the first part of it. Now let us go into the second part of it, part B of it. So in the part B, we are having the first part again, which is given the values of x of n and h of n. X of n is given as 1, 0, 2, 1, and the arrow is present at 0. And h of n is given as 1, 4, 2, 1. And what we should find? We should find the response y of n. We should find the response y of n. Y of n is nothing but x of n convolved with of h of n. X of n convolved with of h of n. So let me write x of n here 1, 0, 2, 1, and here h of n 1, 4, 2, 1. So 1 times 0 times 2 times 1 times 4 times 0 times 8 times 4 times 2 times 0 times 4 times 2 times 1 times 0 times 2 times 1 time. So now the diagonals, we will add all the diagonal elements. 1, 4 plus 0 is 4, 2 plus 2 is 4, 8 plus 1 plus 1 is 10, 4 plus 4 is 8, 2 plus 2 is 4, is 1. So therefore you can see the arrows, the arrow is present here. Lower limit here is minus 1, here the lower limit is minus 1. For the output, the lower limit is always going to be the sum of the lower limits of x of n and h of n. The lower limit of the output y of n is always going to be the sum of lower limits of x of n and h of n. The lower limit here is minus 1 and here it is minus 1. For here it's going to be minus 2, which is nothing but minus 1 plus minus 1. Minus 1 plus minus 1. So the lower limit of y of n is minus 2, minus 2, minus 1, 0. At 0 we are going to have an arrow. At 0 we are going to have an arrow. So you are going to have signal 1, 4, 4, 10, 8, 4, 1. 1, 4, 4, 10, 8, 4, 1. This is the A part of B. Next let us do the B part. So in the case of a B part, the h of n is asked, x of n is given and y of n is given. The x of n is given to be 2, 5, 1, 4 and the arrow is present at 5, and the output y of n is given to be 2, 9, 17, 21, 11 and 12, and the arrow is present at 17. So in this question, strangely, x of n, which is the input, and y of n, which is the output, both are given. And what is asked here? And what is asked here is nothing but the h of n. First of all, tell me how many samples are present in x of n? 2, 5, 1, 4. It means that the L1 is going to be 4 units. The output L is going to be 1, 2, 3, 4, 5, 6. 6 units. And we have a relation that the L is always going to be L1 plus L2 minus 1. Where L1 is the number of samples in x of n, and L2 is the number of samples in h of n, and L is the number of samples in output y of n. Right, so therefore, you know the L, which is 6, you know L1, which is 4, plus L2 minus 1. So therefore, the value of L2 is equal to 3 units. The value of L2 is going to be 3 units. So therefore, h of n, which is A, B, C. What we know is the lower limit of the output is going to be sum of the lower limits of input and the impulse response. LL1 is the lower limit of input, LL2 is the lower limit of the impulse response. We know the lower limit of the output. What is that? 0, minus 1, minus 2. The lower limit is starting at minus 2. We know the lower limit of x of n, which is minus 1. And LL2, which implies that the value of LL2 is going to be minus 1. So the arrow comes here because the lower limit of the h of n is also minus 1. So now let us do the convolution of x of n and h of n. The convolution of x of n and h of n. So 2, 5, 1, 4, A, B, C. So 2A, 5A, A, 4A. 2B, 5B, B, 4B. 2C, 5C, C, 4C. Now let me keep the diagonals. Right, so now let us start. The first sample is 2A, the second sample is 5A plus 2B, and so on, and the last sample is 4C. So the first sample is going to be what? 2A, which is equal to the of 2. It means that the value of A is equal to 1. Second sample is 9. Here it is 5A plus 2B. 5A plus 2B is equal to 9. 2B is equal to the of 4, and the value of B is equal to the of 2. If you see the last sample, you are having 4C. 4C is equal to 12 and C is equal to 3. So your ABC is nothing but 1, 2, 3. The ABC is nothing but 1, 2, 3, and the arrow is present at B. The arrow is present at B. Right? So now let us do the question number 4. And the question number 4 is on the concept of Fourier series. First of all, let me read the question. For the signals given below, comment on the first part is even harmonics, second part is odd harmonics, and third part is the nature of CK, AK and BK. Nature of CK, AK and BK. The first signal which is given to us is signum of sin t. The first signal which is given to us is signum of sin t. We know sin t function. The sin t function is something like this. Signum t we know. Signum t is equal to 1 for t greater than 0 and it is equal to minus 1 for t less than 0. This is nothing but the signum function. Now when we talk about signum of sin t, in the place of t we are going to keep sin t. In the place of t we are going to keep sin t. So signum of sin t is equal to 1 for sin t greater than 0 and it is equal to minus 1 for sin t less than 0. Signum of sin t is equal to 1 for sin t greater than 0 and it is equal to minus 1 for sin t less than 0. So we know this is the part where sin t is greater than 0 and this is the part where sin t is less than 0. So whenever sin t is greater than 0, then signum of sin t is equal to 1. Whenever sin t is less than 0, then signum of sin t is going to be minus 1. So let me draw it below it only. So wherever it is greater than 0, till here it is greater than 0. There the signum of sin t is going to be 1. Wherever sin t is less than 0, there it is going to be minus 1. 1 and minus 1. So this is how the signal is going to be. And sin t is going to have a period of 2 pi. So it is pi, 2 pi. So signum of sin t signal is going to be this one. This is a graphical representation of the signal of sin t. Now we have to comment on the even harmonics, second one odd harmonics, and third one nature of Ck, Ak and Bk. You can comment upon the even and odd harmonics only by the property of half wave symmetry. What is half wave symmetry? If I have a signal x of t, I will check the half wave symmetry when it satisfies x of t plus or minus t by 2 is equal to the of x of t. Where t, capital T is the fundamental time period of the signal. Where capital T is the fundamental time period of the signal. So when you are having a signal x of t plus or minus capital T by 2 is equal to x of t or minus x of t. Plus x of t or minus x of t. This is what we call as the property of half wave symmetry. So in this, if it satisfies x of t plus or minus capital T by 2 is equal to x of t, we call it as an even half wave symmetry. We call it as an even half wave symmetry. When the signal satisfies even half wave symmetry, signal will only have even harmonics. When the signal satisfies the even half wave symmetry, it will only have the even harmonics. If it satisfies x of t plus or minus t by 2 is equal to minus of x of t is equal to minus of x of t, then it satisfies odd half wave symmetry. Then it satisfies odd half wave symmetry. So x of t plus or minus capital T by 2 is equal to minus of x of t. We call it as an odd half wave symmetry. We call it as a odd half wave symmetry. When the signal satisfies odd half wave symmetry, it will only have odd harmonics. It will only have odd harmonics. So let us see this signal, which one it is going to satisfy. Whether it is going to satisfy even half wave symmetry or it is going to satisfy odd half wave symmetry. So you can either do the advancing or delay. But we have to do either advancing or delay by half its time period. We have to either do advancing or delay by half its time period. Let us do that. So this particular signal, I want to delay it by half its time period. What is that half time period? The fundamental time period of the signal is going to be 2 pi. The fundamental time period of the signal is 2 pi. So when I delay the signal by pi, what happens? This part will come here. This part will go. So this is how the signal is going to be. This is 1 and this is minus 1. And this is 1 and this is minus 1. And this is x of t minus pi. We are shifting the signal by pi units to the right. We are shifting the signal by pi units to the right. So the signal is going to become something like this. Now you check whether this is equal to x of t. Of course not, because here you are having 1 between 0 and pi, and here you are having minus 1 between 0 and pi. So this cannot be x of t. Can it be minus of x of t? What is minus of x of t? Minus of x of t is that minus of the amplitude what is there earlier. So here it is 1 here. You will have minus 1 after doing the minus of x of t. Here there is a minus 1. Multiplied by minus 1, it becomes plus 1. I'm sure you are able to understand it. On this particular signal, we are applying the magnitude reversal. Minus of x of t. And you can check. This is exactly equal to the minus of x of t. Whatever x of t minus pi we are doing, this is exactly equal to the of minus of x of t. It means that the signal will only have odd harmonics because this is satisfying odd half wave symmetry. When the signal satisfies odd half wave symmetry, it will only have odd harmonics. And the even harmonics are going to be equal to 0. Even harmonics will be equal to 0. the total even harmonics in the signal is going to be equal to the of 0. This is very important. This is a very, very important point as far as the gate examination is concerned. 60% of your questions will be based on half-wave symmetry concept, and especially on odd half-wave symmetry. So when it satisfies the odd half-wave symmetry, when you're shifting the signal by half its time period, it will be equal to the negation of the signal, minus of x of t. And you can see, when I'm shifting the signal by half its time period, it is equal to the of minus of x of t. It means the signal will only have odd half-wave, odd harmonics, and it will not have any even harmonics. So we have checked for the first question, which is part A. And now let us look for the, so we have commented on even harmonics, we have commented on the odd harmonics. Now we should also comment on the nature of CK, AK and BK. We should also comment on the nature of CK, AK and BK. So the signal that we are having is going to be something like this. This is my signum of sin t. Right? So we know that the signal will be equal to 0 for the value of k being even. Or for that matter, even the values of AK and BK will be equal to 0 for the value of k being even, because it's satisfying the odd half-wave symmetry. Now, if you observe the signal nature, the signal, if I take it as x of t, the nature of the signal is that it is going to be real and odd. The nature of the signal is that it is going to be real and odd. Whenever the signal satisfies real and odd, the value of BK will not be equal to 0 and the values of AK will be equal to the of 0. So especially I should say, whenever the signal is going to be real and odd, the values of AK and A0 will always be equal to the of 0. This is a very important point. The values of AK and BK will always be equal to 0 for every value of K, for all K. For all values of K, it's going to be equal to the of 0. What about CK? Whenever the signal is x of t is real and odd, whenever the signal x of t is real and odd, the nature of CK will be imaginary and odd. The nature of CK will be imaginary and odd. These points are very, very important as far as the gate examination is concerned. So when I talk about the signal which is going to be real and odd, it will only have the values of BK and it will not have any values of AK and A0. The values of A0 and AK and A0 will be equal to 0. AK represents the coefficient of cosine function, A0 is a DC component, and BK represents the coefficient of the sine component. So clearly the values of AK and A0 will be equal to 0 and the value of BK is generally not equal to 0 in the case of a real and odd signal. So when it comes to the value of CK, the CK nature is going to be imaginary and odd whenever the signal satisfies the real and odd nature. Whenever the signal x of t satisfies the real and odd nature, the complex Fourier coefficient CK is always going to satisfy imaginary and odd. So on the signum of sin t, we have commented on the required things which are asked in the question. Now let us move into the second part. The second part of the question is something like this. So the part B question is given something like this. And for this signal, we have to again check. What is the first part of the question? we have to check the nature of the harmonics, even harmonics and the odd harmonics, and then we have to comment on the CK, AK and BK. So whenever you are commenting on even and odd harmonics, we have to always check the concept of half wave symmetry. We should always check the concept of half wave symmetry. See, this signal clearly did not have any DC component, because whatever positive part you are having, the same part you are having in the negative. The area of both is same. But in this signal you can see it is having only the positive part. It always indicates that the signal is having the DC component. But whenever you are checking the half wave symmetry, you have to remove the DC component from the signal. So when I remove the DC component, so the DC component will be given by the formula 1 by t integral of 0 to t x of t. Okay, so the period of the signal, if I take the period of the signal, it will be from, I can take it from -1 to 3. Either I can take it from 0 to t or I can take it from -1 to 3. Only thing is that you have to ensure that you are taking the total period. So if I take it from -1 to 3, x of t dt, 1 by t. Time period is going to be 4 units, -1 to 3. The value of x of t from -1 to 1 is going to be 4. And the signal from 1 to 3 is going to be 2 dt. So 1 by 4 times that of 4 into 2. Here also 2 into 2. So 6 plus 4, 8 plus 4, it's 12 by 4, which is going to be 3. So 3 is going to be the DC component of the signal. Let me remove the DC component from the signal. X of t minus 3. Let me remove the DC component from the signal, that is x of t minus 3. So if I remove the DC component, 4 minus 3 becomes 1. 2 minus 3 becomes minus 1. So from -1 to 1 and then from 1 to 3. Okay. Right, so this is the signal that we are having. So I've removed the DC component from the signal. Remember always, whenever we are checking the half wave symmetry is a very important concept. So whenever we are checking the half wave symmetry, you should always remove the DC component from the signal. And 3 is the DC component. If I remove, the signal is going to be something like this. Now I am going to apply the shift of half time period. Shift of half time period is nothing but the total time period of the signal is 4 units. If I shift it by half its time period, then it is going to be what? +2, +2, +2 and +2. So whenever I am shifting the signal towards right by 2 units, I can easily add a 2 units duration for this one. Then -3 becomes 1. Sorry, -3 becomes -1 and -1 becomes 1. And then this becomes 1 to 3. Right? Now you will see this signal is going to be equal to the top minus of x of t minus 2 minus 3. Okay, so whatever above signal you are having, it will be minus of right. So if I take this particular signal as y of t, this is going to be y of t minus 2, where 2 is nothing but the half time period. So y of t minus 2 is going to be equal to the of minus of y of t. You can please check it. Y of t minus 2 is going to be equal to the of minus of y of it. It means that it is satisfying the odd half wave symmetry. Whenever it satisfies the odd half wave symmetry, it will only have the odd harmonics. It will only have the odd harmonics. And the even harmonics are equal to 0. Even harmonics will be equal to 0. It will only have the odd harmonics and the even harmonics will be equal to the of 0. Right? So the signal x of t, if the signal y of t is having only odd harmonics, signal x of t is also going to have only odd harmonics. Okay, so we are able to comment on the even harmonics and the odd harmonics. Next thing we have to comment on the nature of CK, AK and BK. Here also what I can do is that I can write my CK value, AK value and BK value will be equal to 0 for the value of K being even. For the value of K being even. For all the values of K being even, we're going to have the values of CK, AK and BK is equal to the of 0. Is equal to the of 0. Now again, if you observe the nature of signal x of t signal satisfies real and even. Why? When you apply the time reversal on the signal, it will be the signal itself. It indicates that it's going to be real and even. So whenever the signal is going to be real and even, then CK is also going to be real and even. The nature of CK is also going to be real and even. Very important point, that whenever the signal is going to satisfy real and even, then CK also satisfies real and even. CK also satisfies real and even. Next one is the values of AK and BK. Whenever the signal is real and even, the value of BK is always equal to 0. The values of BK is always equal to 0 for all K. The value of BK will always be equal to the of 0. Okay. AK will be there. AK may not be 0. But BK is definitely going to be equal to the of 0. BK is nothing but the coefficient of sign components. BK is nothing but the coefficient of sign components. And the coefficient of sign components is going to be 0 because sign itself represents the odd component of the signal. Sign itself represents the odd component of the signal. So if the signal does not have any even component, the signal does not have any odd component, it means that the value of BK should be equal to the of 0. So this is about the nature of the values of CK, AK and BK. AK is not going to be equal to the of 0. CK is going to be real and even. BK will be equal to the of 0. So this is about the second part of the question. Now let us go into the part B of the question. Okay, part B or second part of the question. 4.2. So 4.2 says that we have to find the complex Fourier series coefficient for the following signals. So 4.2, we have to find the complex Fourier series coefficients for the following signals. The first part is given as, inside the 4.2, the A part is given as x of t is equal to sin pi t plus cos 2 pi t plus cos 5 pi t plus sin 7 pi t. We are having sum of sinusoids. This is nothing but the trigonometric Fourier series. This is nothing but trigonometric Fourier series which is given by a0 plus summation ak cos k omega naught t plus bk sin k omega naught t. So the first thing that you have to do is that we have to find the values of omega naught. So omega naught will be the fundamental frequency. Omega naught will always be the highest common factor of the frequencies in the signal. The highest common factor of the frequencies in the signal. Here I am having omega 1, omega 2, omega 3, omega 4. Omega 1, omega 2, omega 3 and omega 4. So the highest common factor of this is nothing but pi, and then 2 pi, and then 5 pi, and then 7 pi. The highest common factor is going to be pi itself. So pi is going to be the fundamental frequency. This pi is nothing but omega naught. So you are having sine omega naught t plus cos 2 omega naught t plus cos 5 omega naught t plus plus sine 7 omega naught t. So you are having what? Sine omega naught t plus cos 2 omega naught t plus cos 5 omega naught t and then plus sine 7 omega naught t. So this is the trigonometric Fourier series coefficients. So therefore you can compute the values of AK and BK. A naught is clearly is equal to 0 and the value of A1 is equal to 0 cos omega naught t. There is no term called as cos omega naught t. And the non-zero term is going to be B1. B1 is 1. And then we have second harmonic. A2 is available. A2 is 2 but B2 is not there. And then we have fifth component. A5 is equal to, A2 is equal to 1. The coefficient of A2 cos 2 omega naught term will be A2. The coefficient of cos 2 omega naught t term will be the A2. So the value of A2 is equal to 1 and the value of B2 is equal to 0 because of the fact that there is no sine 2 omega naught t term. There is no sine 2 omega naught t term. So therefore the value of B2 is equal to 0. And then we have A5. The value of A5 is equal to 1 and then we have the value of B5 is equal to 0. We have A7 is equal to 0 but we have the value of B7 which is equal to 1. But what we have to do, we have to compute the complex Fourier series coefficient. We have to compute the complex Fourier series coefficient. So when you compute the complex Fourier series coefficient, of course C0 will be equal to 0. C1 will be A1 minus JB1 by 2. A1 minus JB1 by 2 which is nothing but minus J by 2. C minus 1 is going to be C1 conjugate which will be J by 2. And then we have the second harmonic. C2 will be A2 minus JB2 by 2. A2 is 1 and B2 is 0. So therefore you have C2 is going to be 1 by 2 and C minus 2 will also be C2 conjugate which is going to be 1 by 2. And then we will have C5 and then we will have C5. What would be the value of C5? C5 is going to be A5 minus JB5 by 2. The value of A5 is 1, the value of B5 is 0, so again you will have 1 by 2. If C5 is 1 by 2, C minus 5 which is C5 conjugate will also be 1 by 2. And then we will come to C7 which is going to be A7 minus J B7 by 2 which is equal to the top. A7 is 0 and B7 is 1 minus J by 2. So the value of C minus 7 is going to be equal to the top, the conjugate of C7 which is J by 2. So what are the non-zero values? C1 is going to be minus J by 2. C2 is going to be 1 by 2. C5 is going to be 1 by 2. C7 is going to be minus J by 2. Now C minus 1 is conjugate of it which is J by 2. C minus 2 is going to be 1 by 2. C5 is going to be 1 by 2. And C minus 7. C minus 5 and C minus 5. So these are the complex Fourier series coefficients for the trigonometric Fourier series which is given in the question. So this is also an important model because many a times the question can be asked, given the complex Fourier series coefficient we have to find the trigonometric Fourier series, or it can also be asked in a way that given the trigonometric Fourier series we have to find the complex Fourier series coefficients. I'm sure this particular question is clear. You can please go through it. So second part is that okay, so second part of the question is that for 2b, if the signal x of t is having the Fourier series coefficient as ck, what is the Fourier series coefficient of x of 2t plus 1? And what is the Fourier series coefficient of d by dt of x of t? X of 2t plus 1 will have the Fourier series coefficient as shifting property. Forget about the scaling property. Shifting property x of t plus 1 is going to be what? Ck e power j k omega naught plus 1. Ck e power j k omega naught plus 1. Now, if I am doing the scaling is not going to affect the complex Fourier series coefficient. The scaling is not going to affect the complex Fourier series coefficient. This is the A part of it. B part of it is that you have to find the d by dt of x of t. You have to find the Fourier series coefficient of d by dt of x of t. The Fourier series coefficient of d by dt of x of t is going to be j k omega naught ck. It's going to be j k omega naught ck. So d by dt of x of t will have the complex Fourier series coefficient as j k omega naught multiplied by ck. Time shifting property, time scaling property, and time differentiation property. These three properties are very, very important as far as the gate examination is concerned. These three properties are very, very important as far as the gate examination is concerned. So with this we complete the fourth question, which is based on the complex Fourier series and Fourier series. So the gist is that, so whenever the signal is going to be real and even, then pk will be equal to 0 and the nature of ck is going to be real and even. Whenever the signal is real and odd, the nature of ck is going to be imaginary and odd, and always the values of ak and a0 will be equal to 0. When it comes to the of even harmonics and odd harmonics, so how we are going to check it? We are going to check using the property called as half wave symmetry. So whenever the signal satisfies the odd half wave symmetry, which is the most important case, signal will only have the odd harmonics, whereas the even harmonics will be equal to 0. When the signal is only real, if it is not satisfying even or odd, if it is only real, it means that the nature of ck will always satisfy even conjugate, which we didn't do any problem, but this is also important. So whenever the signal is only real, then the ck is going to be satisfying even conjugate, and the signal will have both ak and bk. The signal will have both ak and bk. Is it clear? So fourth part is based on the fourth question is based on the complex Fourier series and the trigonometric Fourier series. And the relation that we have seen between ck and ak and bk is that ck will be equal to ak by 2 minus j bk by 2. So the next question is both based on the Fourier transform, and Fourier transform and Fourier series is the most important part of the whole signals and systems. So here we are going to do the problem on the Fourier transform. So for the signal x of t shown in the figure below, and let me draw the figure. So we have to find the Fourier transform of x of t. We have to find the Fourier transform of the signal x of t. This is the first part of the question. And part B is that we have to find the area of x of omega. We have to find the area of x of omega. Third part is that we have to find the area of mod of x of omega whole square, d omega. We have to find the area of mod of x of omega whole square. Part D is the nature of x of omega satisfies. Nature of x of omega satisfies. First one real and even, second one real and odd, third one imaginary and odd, and fourth one is even conjugate. So the continuation of the signal is that the Fourier transform of x of t into x of minus t is always real. And the last part of the question is that the Fourier transform of x of t into e power j2t is dash. So we will go one by one. First of all, we will find the Fourier transform of this particular signal. We will find the Fourier transform of this particular signal. Let us see the amplitudes of the signal. So the amplitudes of the signal are given as 2 and 1. Now whatever signal I am having as x of t, I can decompose into parts. First part, second part, and third part. So x of t can be written as addition of x1 of t, x2 of t, x3 of t. Right? So basically this question is framed on the gate function. And gate function is one of the most standard functions in the Fourier transform. Gate function is one of the most standard function in the Fourier transform, which says that when you are having a symmetrical rectangular pulse, when we are having a symmetrical rectangular pulse from minus t by 2 to t by 2, and the amplitude of the signal is 1, we represent it with of gate suffix t of t. G is nothing but gate or rectangular suffix t of t, where t is nothing but the total time period of this gate function. T is nothing but the total time period of the gate function. It is going to have the Fourier transform which is given by T SA of omega t by 2. And the shortcut to remember this one is given as below. T will always represent the area of this one. What is the area of this rectangular pulse? It's a rectangular, right? Rectangle will always have the area as length into breadth. Length is 1 and breadth is going to be t. So this coefficient of SA function will always represent the area of this particular SA gate function. This will always represent the area of the gate function. T by 2 will be the half time period. T by 2 will always be the half time period. T by 2 will always be the half time period. Is it understood? Capital T here as a coefficient of SA function will always represent the area of the rectangular pulse, and T by 2 will always represent the half time period. Whereas SA function, SA of theta is going to be sine theta by theta. SA of theta is going to be sine theta by theta. Now let us go ahead. Using this particular formula, we can write the Fourier transforms of x1 of t. x1 of t is nothing but g2 of t. x1 of t is nothing but g2 of t. Right? So you are having from minus 1 to 1. Minus 1 to 1, it means that gate function is of duration 2 units and it's a symmetrical function, which is going to have the Fourier transform as area is 2, SA of half duration is 1, omega. x2 of t is basically nothing but the gate 4 of t. It means that 4 units of gate rectangular pulse. So 4 SA of half duration is going to be 2 units. x3 of t can be represented in terms of the symmetrical rectangular pulse from minus 1 by 2 to 1 by 2. This is nothing but G1 of t. G1 of t. It means that gate pulse is of duration from minus 1 by 2 1 by 2, duration of 1 unit. So G1 of t is going to have a Fourier transform as the area is going to be 1 unit, SA of half duration is 1 by 2. Right? So now, what is the relation between G1 of t and x3 of t? What is the relation between G1 of t and x3 of t? This is a standard function in the case of Fourier transform, whereas this is a shifted function. I cannot directly write the Fourier transform for this function. What I can do is that I can write in the form of the the shifted function of G3 of t, G1 of t. So G1 of t, if I am applying the shift of how many units, if I should have this particular function, I should apply the shift of, let me say, it's going to be 7 by 2. If I shift it by 7 by 2, if I shift the signal by 7 by 2, then I'm going to have 7 minus 1, which is 6 by 2, which is 3, 7 plus 1, which is 6 by 2, which is 4. Right, so therefore it's going to be G1 of t minus 7 by 2. G1 of t minus 7 by 2. This is nothing but x3 of t. x3 of t is equal to g suffix 1 t minus 7 by 2. So g1 of t we already know the Fourier transform. Now we use the time shifting property. Again, a very important property in the gate examination, time shifting property. So time shifting property says that this function is going to have the Fourier transform as whatever Fourier transform we are having here, sa of omega by 2 into e power minus j omega 7 by 2. Minus j omega 7 by 2 using the formula that if you are having a function x of t which is having the Fourier transform as x of omega, then x of t minus t naught will have the Fourier transform as x of omega multiplied by e power minus j omega t naught. Okay, so using this particular thing, so what we did is that we don't know directly the Fourier transform of this function, so we took the standard function in the Fourier transform and we have written the Fourier transform of it, and using the time shifting property we are able to write the Fourier transform of this particular function, which is sa of omega by 2 e power minus j omega 7 by 2. Now the signal x of t is nothing but a combination of x1 of t, x2 of t and x3 of t. x of t is nothing but x1 of t plus x2 of t plus x3 of t. So what happens to the Fourier transform? What happens to the Fourier transform? Fourier transform of this function, let me consider it as x of omega, which will be equal to x1 of omega, which is the Fourier transform of x1 of t, plus x2 of omega, the Fourier transform of x2 of t, plus Fourier transform of x3 of t, which is x3 of omega. So if I write all of them, it's going to be what? 2 sa of omega plus 4 sa of 2 omega plus sa of omega by 2 into e power minus j omega 7 by 2. Clear? So with this we complete the first part of it, which is the Fourier transform of x of t. The next one we have to find is area of x of omega. Area of x of omega. You know, always using the area property of Fourier transform, the area of x of omega is going to be 2 pi small x of 0. 2 pi small x of 0, where small x always represents the time domain, capital X always represents the frequency domain. Small x of 0 is nothing but the value of x of t at t is equal to 0, which is 2. So therefore, it's going to be 2 pi multiplied with it of 2, which is 4 pi. The area of x of omega, d omega, is going to be 2 pi multiplied by x of 0, which is going to be equal to the of 4 pi. Now, third one is that we have to find the area of mod of x of omega whole square. Area of mod of x of omega whole square. See, whenever you see this particular term, one thing that you have to come to mind is the Parcels theorem. One thing that has to come to mind is the Parcels theorem to find the energy. The energy is given by 1 by 2 pi times the of integral minus infinity to infinity mod of x of omega whole square d omega. Mod of x of omega whole square d omega. See, so basically 2 pi multiplied by the energy is going to give you the value of integral minus infinity to infinity mod of x of omega whole square d omega. Now how to find the energy? How to find the energy of the signal? We can find the energy not using the frequency domain, because to use the frequency domain and find it in this case is going to be very difficult. What we can do? We can use the energy, we can find the energy of the signal using the time domain. In the time domain, the formula is going to be infinity to infinity x square of t dt. X square of t dt. So x square of t, we know what is x of t. X of t is equal to 2 between minus 1 and 1. X of t is equal to 1 between minus 2 and minus 1 and 1 and 2. And x of t is also 1 between 3 to 4. So let us split it. So we are finding the energy. So between minus 2 and minus 1, the value of x of t is going to be 1 square dt. Between 1 and minus 1 and 1, the value is going to be 2 square tt plus between 1 and 2 it's going to be again 1, and then between 3 and 4 it's again going to be 1. So what is this value? You can find out the energy. So the energy is given by 1 into 1 plus 4 into 2 plus 1 into 1 plus 1 into 1. So therefore it is going to be 8, 9, 10, 11. So the energy of the signal is going to be 11 joules. Energy of the signal is going to be 11 joules. Then what is the value of this one? 2 pi into 11 joules, which is going to be 22 pi. Integral minus infinity to infinity mod of x of omega whole square d omega is going to be 22 pi. So with this we complete the third part of it, C part of it. Now let us come to the D part of it. What is the nature of x of omega? What is the nature of x of omega? The first option is real and even, second option is real and odd, third option is imaginary and odd, and the last option is even conjugate. Please tell me one thing. When are we going to have x of omega real and even? We have covered the same point in the Fourier series and we are coming to the same point in the Fourier transform. We will always have the Fourier transform to be real and even when the signal itself is going to be real and even. Do you think this particular signal is real and even? It would have been real and even if we didn't have 3 to 4. This signal will not satisfy, this property will not be satisfied because of the fact that you are having something from 3 to 4. Had it been that you had something like from -3 to -4 the same thing, then this would have been a real and even signal. This would have been a real and even signal. But because you don't have any counterpart of 3 to 4 in the negative frequency domain, so therefore this signal cannot be real and even, nor it can be real and odd. Okay, so the two options which can be eliminated is that x of omega cannot be real and even and x of omega cannot be imaginary and odd, because when the signal is real and odd, then only you will have x of omega to be imaginary and odd. But one thing that we are sure for this signal is that this signal is going to be a real signal. This signal is going to be a real signal. So whenever x of t is real, then x of omega is going to satisfy even conjugate. This is a very, very important point, that whenever signal x of t is real, x of omega satisfies even conjugate. If we are having real and even here, then it satisfies real and even. If we are having real and odd here, then it satisfies imaginary and odd. So because of the fact that we know that the signal is only satisfying the real, it is not even nor it is odd, so therefore you are going to have x of omega satisfying the even conjugate property. It is going to satisfy the even conjugate property. Now let us come to the part E of it. X of t into x of minus t, Fourier transform is always real. And this has already been asked in the gate before, that x of t multiplied by x of minus t, what is the nature of it? So what is the nature of x of t Fourier transform of? I'll do it again. What is the nature of Fourier transform of x of t into x of minus t? Please tell me one thing, that if I have a signal x of t which is having the Fourier transform as x of omega, if I'm having the signal x of minus t, it will have the Fourier transform as x of minus omega using the time reversal property. Time reversal property, that whenever I apply the time reversal here, there will also be a frequency reversal. But what we know is that the signal x of t is a real signal. The signal x of t is a real signal. Then x of omega will satisfy even conjugate. X of omega will satisfy even conjugate. What does it mean? it means that x of minus omega will be equal to x of omega conjugate. X of minus omega will be equal to that of x of omega conjugate. So with this we complete the fourth question, which is based on the Fourier transform. So now let us enter into the fifth part of the question. Now let us go into the sixth question. A system is described by a differential equation d square y by dt square minus dy by dt minus 20y of t is equal to x of t. D square y by dt square minus dy by dt minus 20y of t is equal to x of t. Assuming that y of 0 is equal to 0 and y dash of 0 is equal to 0, the first part of the question is that considering the system is stable and non-causal, the impulse response of the system is dash. So we have to find the impulse response of the system. Second part of the question is that the steady state value of the output for step input considering the system to be causal. Third part of the question is the output for a sinusoidal input x of t is equal to 3 sin 2t for the above system if the pole at s is equal to 5 is replaced by the pole at s is equal to minus 1. And comment on the output for the above if its pole is not replaced. Fourth part of the question is, for any system to be stable, all the poles must lie in the left half of sigma equal to 0, true or false. Fifth part of the question is, ROC of the non-causal signal is always both-sided, provided there exists a Laplace transform, true or false. So we will see the questions one by one. Let us first of all focus on the first part of the question. Considering the system to be causal and First let us focus on the first part of the question. Considering the system to be stable and non-causal, the impulse response system is. So d square y by dt square minus dy by dt minus 20y of t is equal to x of t. If I apply the Laplace transform on both sides, s square into y of s minus s into y of s minus 20y of s is equal to x of s. So therefore y of s taken as common, s square minus s minus 20 is equal to x of s. So therefore the y of s by x of s is going to be 1 by s minus 5 into s plus 4, which can be written as a by s minus 5 plus b by s plus 4. So let us find the values of a and b. A is equal to 1 by s plus 4 for the value of s is equal to 5, which is 1 by 9, and the value of b is equal to 1 by s minus 5 for the value of s is equal to 4. S is equal to minus 4, which is minus 1 by 9. So we found out the values of a and b to be 1 by 9. So therefore 1 by s minus 5 minus 1 by s plus 4. Okay, so this is nothing but your h of s. Right? Now the question is that we have to find the impulse response considering the system to be stable and non-causal. See, you are having two poles. One pole is given at s is equal to 5. The other pole is given at s is equal to minus 4. So given there are two poles, there are three types of ROCs which is possible. Always, whenever there are two poles, we can always have three types of ROCs. The first type of ROC is sigma greater than 5. The second type of ROC is sigma between -4 and 5. And the third type of ROC is sigma less than that of -4. Here, whenever you are having a right-sided ROC, always system is causal, and because it is not covering sigma is equal to 0, so therefore it is not stable. Here, the system is going to be stable because it is covering sigma is equal to 0, and it is not causal because it is not right-sided ROC. And the left side, if you observe, sigma less than -4, it is causal, it is non-causal because it is not a right-sided ROC, and it is not stable because of the fact that it is not covering sigma is equal to 0. The desired region is where the system is going to be stable and non-causal. And this is the region where the system is stable and non-causal, where the ROC is going to be sigma between the of -4 and 5. So sigma less than -4 and sigma greater than -4 and sigma less than 5. This is the ROC. Sigma greater than -4 and sigma less than 5. So this part, sigma less than 5, should be written in terms of anti-causal part, whereas sigma greater than -4, it means that this part has to be written in terms of the causal function. So to write this in terms of anti-causal, I will do minus of minus. In that case, what will happen is that 1 by 9 minus -1 by s minus 5 is going to have the -1 by s minus 5 is going to have the inverse Laplace transform is going to be equal to the of e power 5t u of minus t. It's going to have the ROC as e power 5, it's going to have a inverse Laplace transform as e power 5t u of minus t. Minus, you're having s plus 4, 1 by s plus 4, which can be written as e power minus 4t u of t. Okay, so therefore you can take minus 1 by 9 as common. So the impulse response is going to be e power 5t u of minus t plus e power minus 4t u of t. Right, so I think it's clear. The impulse response is going to be minus 1 by 9 e power 5t u of minus t plus e power minus 4t u of t. So this is the first part of the question. Second part of the question is that the steady state value of the output for step input. See, we know h of s, which is y of s by x of s, is going to be equal to the of 1 by s minus 5 s plus 4. So whenever I take the step input, it means that x of t is equal to u of t. Then what is x of s? The value of x of s is going to be 1 by s, isn't it? The value of x of s is going to be 1 by s. So if I substitute here, I will get the output y of s is going to be 1 by s into s minus 5 into s plus 4. Because the steady state value has been asked, considering the system to be causal. We are considering the system is going to be causal. In that particular case, if I want to apply the final value theorem, what is the formula? Y of infinity is going to be limit s tends to 0, s into y of s. But can I apply the final value theorem? To apply the final value theorem, you have to ensure that all your poles lie in the left half of the j omega axis, plus the system is going to be causal. You have to ensure that all poles of s into y of s, all poles of s into y of s, so s into y of s is basically equal to the top 1 by s minus 5 into s plus 4. In order to apply the final value theorem, you have to ensure that all your poles are lying in the left half of the j omega axis. But you can see one of the pole is present in the right half of the j omega axis. Therefore, final value theorem cannot be applied and the output is going to be unbounded. the output is going to be unbounded. We cannot apply the final value theorem for the fact that your pole is present in the right half of the j omega axis. So therefore we have done the second part. The third part is that the output of a sinusoidal input when x of t is going to be equal to the root of 3 sine 2t. When x of t is equal to the root of 3 sine 2t, for the above system, if the pole at s is equal to 5 is replaced by pole at s is equal to -1. We know the transfer function of the system. I'm sure this part is understood. Let me erase the board. So see here, the third part of the question is that the output of sinusoidal input, the output for sinusoidal input x of t, which is equal to 3 sine 2t. X of t is equal to 3 sine 2t for the above system. If the pole at s is equal to 5 is replaced by the pole at s is equal to -5. So you are having the pole at s is equal to 5. If you are replacing the pole with s is equal to -1, then the change to transfer function is going to be something like this. So in this case, I wanted to find out the output of the system. In this case, I wanted to find out the output of the system. One thing that is very, very important in the gate examination is that the response of an LTI system for a sinusoidal input. So whenever you are giving any sinusoidal input, A sine omega naught t, the output of the system is going to be A multiplied by M multiplied by sine omega naught t plus phi, where M is nothing but mod of h of omega at omega equal to omega naught, where phi is going to be angle of h of omega naught. H of omega is nothing but the frequency response of the system. H of omega is going to be the frequency response of the system. Now you try to understand that whenever I am having a transfer function which is having the poles at -1 and -4, always the ROC is going to be left-sided, right-sided, because it's going to be a causal function. Because it is going to be a causal function. Because I've replaced my s is equal to 5 with the of the pole at s is equal to -1. So you're having two poles at -1 and -4, and the ROC is going to be right-sided. Okay. So if this is the case, the system is always stable. Only when the system is stable, I can apply s is equal to j omega to find the frequency response system from the transfer function. Frequency response system from the transfer function. See, please understand this particular part, that whenever you wanted to convert the Laplace transform into the Fourier transform, whenever you wanted to convert the Laplace transform into the Fourier transform by replacing s is equal to j omega, first thing you have to understand is that the system has to be stable. The system has to be. Now the thing is that it is already declared that the system is going to be causal. It is already declared that the system is going to be causal. It is already declared that the system is going to be causal. Causal means always the ROC is going to be right-sided in nature. Always the ROC is going to be right-sided in nature. Now, you have to ensure that when you are converting it into a Fourier transform to get the frequency response system, always the system has to be causal has to be stable in nature. Otherwise, it is not possible. So we know that the system is stable. If the system is not stable, then the output is going to be unbounded. If the system is not stable, then the output is going to be unbounded. If the system is stable, then we can apply the Fourier transform to get out the output of the system. Understood or not? So here what is asked is that I wanted to get the output of a sinusoidal input. Output for the sinusoidal input. So I will be able to calculate only when I know the frequency response system. Frequency response I can get from the transfer function by replacing s with the of j omega. Frequency response I can get by replacing s with the of the j omega. So when I replace s with the of j omega, then what am I going to have? If I replace s with the of j omega, then I'll have h of j omega, which is 1 by j omega plus 1, j omega plus 4. Now I will replace omega with the of omega naught. What is omega naught? The input frequency is going to be 2. j omega naught, which is 2. Right. What is the magnitude of it? The magnitude of it is going to be 1 by under root of 5 under root of 4 plus 16, 20, which is 1 by 10. This is nothing but n. Right. Phi is going to be the angle of it, which if we calculate, it will be equal to that of minus 90 degrees. So if we substitute here, you will get the output y of t is going to be equal to the of a. What is the input? A amplitude is nothing but 3 multiplied by 0.1 sine of omega naught, which is nothing but 2t, and the angle is going to be minus 90 degrees. So this is going to be the output, minus 0.3 sine of 2t minus 90 degrees. You have to understand one thing. If I don't replace the pole with s is equal to 5 instead of s is equal to minus 1, then it is not possible to find the steady state value or the output, because the output is going to be unbounded in nature. The output is going to be unbounded in nature. For example, this is the comment on the output for the above pole if it is not replaced. If the above pole is not replaced, it means if you are having a right side pole, if it is not replaced and your system is causal, if it is not replaced and the system is causal, then you can only have the right-sided ROC. And this system is not stable. If the system is not stable, you cannot replace s with it of j omega. If the system is not stable, we cannot replace s with it of j omega. Please, it's a very important point that whenever you wanted the Fourier transform from the Laplace transform, whenever we want the Fourier transform from the Laplace transform, you should always ensure that the system is going to be stable. A very important point. Here, I will not apply, when I have an actual transfer function, I will not apply the Laplace transform to Fourier transform, because of the fact that if the system is considered to be causal, then it cannot be stable. If the system is considered to be causal, it cannot be stable. So I think we have covered the third part of it. Fourth part of it is that for any system to be stable, all the poles must lie in the left half of the j omega axis, or sigma equal to 0. Is it correct? It's a true or false statement. For any system to be stable, all poles must lie in the left half. This statement is only half true. This statement is valid when the system is both causal and stable. When the system is, 2017 the question has been asked, when the system is causal and stable, then only you can have a poles to be in the left half of the j omega axis. If it is only required for stability, it is not necessary that all the poles must lie in the left half. If you are talking only about the stability, it is not necessary that all the poles must lie in the left half. If you are talking about stability, then the necessary condition is that your ROC must include the sigma is equal to 0. ROC must include the sigma is equal to, this is the necessary condition in the case of a stability. Okay, all the poles must lie in the left half of the j omega axis is not the necessary condition if you are only talking about stability. It will become a necessary condition if you are talking about both stable and causal system. It will become a necessary condition if you are talking about both causal and stable system. But if you are talking only about stability, the necessary condition is going to be that the ROC must include sigma is equal to 0. The ROC must include sigma is equal to 0. The fifth part of the question is that the ROC of the non-causal signal is always both-sided in nature. This is also completely wrong. ROC of the non-causal signal is always right side, both-sided in nature is also absolutely wrong. See, the fifth part is the ROC of the non-causal signal is always both-sided in nature, whether this particular statement is correct or not. See, I will counter this particular point. Can you please tell me what is the ROC for u of t? The Laplace transform is 1 by s and the ROC is sigma greater than 0. So you are talking about the signal which is causal in nature. Now let me make this particular signal non-causal. Let me make this signal non-causal. Is this signal a causal signal or non-causal signal? Because the left side is not equal to 0, so therefore it's a non-causal signal. And this signal can be represented as u of t minus 2. Let us say. I'm sorry. This signal can be represented as u of t plus 2, where I'm shifting by 2 units towards the left. Where I'm shifting the signal towards the left by 2 units. This signal is going to have the ROC, is going to have the Laplace transform as 1 by s into e power 2s, but the ROC is still going to be sigma greater than 0. The ROC is still going to be sigma greater than 0, which is nothing but the ROC which is right-sided in nature. The ROC, because the time shifting property will not change the ROC. The time shifting property will not change the ROC. So this particular point counters the point that when a signal is non-causal in nature, its ROC should be both-sided in nature, which is absolutely wrong. So the fifth statement is false. Even the fourth statement is also false. What is the fourth part? For a system to be stable, all the poles must lie in the left half of sigma equal to 0, which is wrong. And even the fifth part is also false. So with this we complete the sixth part of the question. So now let us go on to the seventh part of the question. And the seventh question is from the topic of Z transform. The seventh question is from the topic of Z transform. First of all, let me read the first part of the question. That is, if x of n is equal to 3 power mod of n, x of n is equal to 3 power mod of n minus 1 by 2 power n u of n. So this is my signal x of n. We have to find the Z transform of x of n. We have to find the Z transform of x of n. This is the first part of the seventh question. Here we have to find the Z transform of the signal x of n. We have to find the Z transform, and Z transform is possible only when the existence condition is satisfied or when there is a common region of signal convergence. When there is a common region of convergence between the different signals. See, if I can expand 3 mod n, I can write it as 3 power n u of n plus 1 by 3 power n u of minus n minus 1. Yes or no? That I can expand this and write it as 3 power n u of n plus 1 by 3 power n u of minus n minus 1. And here you're going to have minus 1 by 2 power n u of n. Please tell me what is the ROC for the causal part? What is the ROC for the causal part? ROC for the causal part is R greater than the 3. ROC in the case of a causal functions is always bounded by the outermost pole. And the outermost pole is nothing but Z is equal to 3. Outermost pole is nothing but the Z equal to 3. So R greater than 3 will be the ROC in the case of a causal function. There is only one anti-causal function whose ROC is going to be R less than 1 by 3. Is there any common region of convergence? R greater than 3, R less than 1 by 3. Is there any common region of convergence? Causal and anti-causal parts fail to have a common region of convergence. Causal and anti-causal parts fail to have the common region of convergence. So I can declare the system to be, I can declare that no common, so I can declare that there is no common ROC. There is no common ROC. If there is no common ROC, then there is no Z transform. I cannot find out the Z transform. See, what you can either do is directly, some students what they do is that directly use the formula a power n u of n Z transform and they calculate it. But it is wrong in this question. Why? Because if you wanted to find the Z transform, you have to ensure first that there is a common region of convergence. If you wanted to write mathematical expression of Z transform of this, it is possible. But whether it is going to have the Z transform or not is purely going to depend on the ROC. If the ROC does not, if there is no common region of convergence, it means that then there is no ROC. If there is no ROC, it means that there is no Z transform. So this particular signal does not have any Z transform. This is the first part of the question. Second part of the question is that y of n is equal to x of n convolved with h of n. Y of n is equal to x of n convolved with h of n. X of n is given as, x of n in this question is given as 1 by 3 power n u of n. And h of n is u of n. Can you please tell me what is the ROC of the Z of n? X of n is going to have the ROC mod Z greater than 1 by 3, and here it is mod Z greater than 3. Mod Z greater than 1. Yes or no? U of n is going to have the ROC as mod Z greater than 1. It indicates that the h of Z is going to have the ROC as mod Z greater than 1. ROC, what is h of Z? H of Z is the transfer function, h of n is the impulse response. So when I apply the Z transform on h of n, I am going to have h of Z. And the ROC of h of Z is mod Z greater than 1. It means it does not include the unit circle. It does not include the unit circle. If h of Z, the Z transform of the impulse response, if it does not include the unit circle, it means that it is an unstable system. System is unstable. If the system is unstable, then the output is going to be unbounded. So in the case of unbounded output, we will never apply the final value. We cannot find the final value because final value will lead to infinity. Final value will lead to infinity. What is the ROC? What is the ROC of y of n? If here the R1 is the ROC, if here R2 is the ROC, R1 is the ROC for x of n, R2 is the ROC for h of n, then y of n is going to have the ROC, which is R1 intersection R2. R1 intersection R2. And the common region of convergence between mod z greater than 1 by 3 and mod z greater than 1 is mod z greater than 1 only. The common region of convergence between mod z greater than 1 by 3 and mod z greater than 1 is nothing but mod z greater than 1. So the ROC for y of n is going to be mod z greater than 1. Third part of the question. Please look at the third part of the question. Third part of the question is that f of z is given as f of z is equal to minus z power minus 2 by 1 minus z power minus 1 whole square plus 1 by 1 minus 2 z power minus 1 whole square. So this is f of z which is given and its ROC is also mentioned, which is mod z greater than 2. And what we have to find? We have to find small f of 3. So in time domain, we have to find the sample value at n is equal to 3. We have to find the sample value at n is equal to 3. See, f of z is going to be what? It's having two components. And the ROC is given as mod z greater than 2 and we have to find f of 3. See, this model question, in a way, it was already asked in previous gate. We tried to improve this question and make an excellent question. What we know is that when you are having a signal a power n u of n multiplied by n, it will always have the z transform is going to be a z by 1 minus z power minus 1 whole square. I'm sorry, a z by z minus a whole square, or in terms of z inverse I can write it as a z power minus 1 by 1 minus a z power minus 1 whole square. This is a standard function in the case of the z transform which has to be remembered. If you don't remember this one, it's very difficult to solve this problem. Okay, so this is a standard function, an important formula as far as the gate examination is concerned. So let me erase this part. Clear? Now, based on this particular thing, we can find the Fourier transform. We can find the inverse Z transform of the above function, and only after finding the inverse Z transform, we can find the value of f of 3. If you see in both the cases, in this case as well as this case, your denominator is almost looking same. If I take the value of a is equal to 1, if I take the value of a is equal to 1, then what am I going to have? I will have z power minus 1 by 1 minus z power minus 1 whole square, which will have the inverse Z transform as n into 1 power n is nothing but 1 itself, n into u of n. But if you observe in the question, it is having z power minus 2, not only z power minus 1. It is having z power minus 2. So if I am multiplying my function with it of z power minus 1, then totally I will have z power minus 2. But if I multiply by z power minus 1, what happens in the other domain? Whenever I multiply any function of z with z power minus 1, there will be an there will be a delay of 1 unit. There will be a delay of 1 unit in the time domain. So it has to be n minus 1 into u of n. It has to be n minus 1 into u of n. So because I required z power minus 2 in the numerator, so what I'm going to do? I'm going to multiply with it of z power minus 1 in the z side. So if I multiply by z power minus 1 in the z side, what happens in the time domain is that it's going to become n minus 1 into u of n. It's going to become n minus 1 into u of n. So this is the case. And in the second case, let me consider the value of a is equal to 2. Let me consider the value of a is equal to 2. If I consider the value of a is equal to 2, then it is 2z power minus 1 by 1 minus 2z power minus 1 whole square will have the inverse z transform value to be n into 2 power n u of n. N into 2 power n u of n. Correct or not? If I put the value of a is equal to 2, then I'm going to have this expression, and in the other side it's going to be n into 2 power n u of n. Now in this expression I don't have z power minus 1. In this expression I don't have any z power minus 1. So what I'll do, I will multiply the whole expression 2z power minus 1 by 1 minus 2z power minus 1 whole square with the of z. So that what happens, that z power minus 1 and z will going to get cancelled out. Then what I will have, whenever I multiply z in the z domain, whenever I multiply z in the z domain, what happens? Whenever I multiply z in the z domain, in the time domain there will be an advancing of 1 unit. If I multiply with the of z power 1, there will be an advancing of 1 unit. If I multiply by z power 2, there will be an advancing of 2 units. If I multiply by z power 3, there will be an advancing of 3 units. So therefore you understand that it is going to be advanced by 1 unit. So n plus 1, 2 power n plus 1, u of n plus 1. So it's going to be advanced by 1 unit. It's going to be advanced by 1 unit. I don't have 2 also. Let me send 2 to the other side. I will multiply by 1 by 2 on both sides. By 2 by 2. So that 2 will get cancelled out. So this is the function you're going to have, n plus 1 into 2 power n u of n plus 1. This is nothing but 1 by 1 minus 2z power minus 1. Right? So I have z power minus 2. I require minus also. So okay, there will be a minus sign. Now if I add whatever is present in the right half, if I add, I'm sorry, here it should be whole square. So if I add the right half, what is the right half? Which is minus z power minus 2 by 1 minus z power minus 1 whole square plus 1 by 1 minus 2 z power minus 1 whole square. So I'm adding the left half. What is the left half? Minus n minus 1 u of n plus n plus 1 2 power n u of n plus 1. Here also it should be n minus 1. Here it should be n minus 1. Clear or not? Now this is my f of n, and this function I can consider it as f of z. Now please calculate f of 3. What is the value of f of 3? The value of f of 3 is going to be minus 2 times it of u of 2 is 1 plus 4 times it of 2 power 3 u of 4, which is 1. So 32 minus 2 is going to be 30. So the answer for this question is 30. Now coming to the last part of the question, which is if h of z is a z transform of the system having pole 0 configuration as shown in the figure. So we are having the pole 0 configuration as shown in the figure. We are having the pole 0 configuration as shown in the figure. So here I'm having a 0 of minus 0.5 and here I'm having 0.5, and there are two poles here, one at 0.1, the other at 0.8. So what is given in this question is that if the system is causal, it is automatically stable. Is it correct or not? If the system is causal, then it is automatically stable. Is it correct or not? If I know that the system is causal, you can see that there are two poles, and I want causal, it means that the ROC is bounded by the rightmost pole. I'm sorry, the ROC is bounded by the outermost pole. So therefore, because of causal, the ROC is going to be outwards in nature, and it is given that it is already causal. So whenever it is causal, the ROC is going to be outwards in nature. Yes or no? Whenever it is causal, the ROC is going to be outwards in nature. And whenever it is outwards, if it covers the unit circle, if it covers the unit circle, then automatically it's going to be stable. Understood or not? Here you can see that there are two poles, 0.1 and 0.8. Yes or no? There are two poles at 0.1 and 0.8. And you can also observe that the ROC, because it is causal in nature, the ROC is going to be outwards in nature, bounded by the outward pole. So there are two poles in which the outward pole is nothing but the pole lying on the outward circle, which is 0.8. So now when the ROC is going to be outwards in nature, it is automatically covering the unit circle. Whenever ROC includes the unit circle, it is always going to be stable in nature. So this particular statement is absolutely correct. Now let us go for the last question. So the last question, let me erase the board. Now let us do the 8th question. It's a very interesting question that has been asked from the concept of DFT. So here, x of n and x of k are 8-point DFT pairs, where x of k is given as x of k square plus 1. X of k is given as x of k square plus 1. X of k is given as k square plus 1. And the value of k is ranging from the top 0 to 7. And y of n is the summation of all the even samples. And the n is changing from the top 0 to 3. Whereas g of n is the summation of odd samples. And again the same range. The question is that you have to find the addition, the square of addition of y of n and g of n. This is what we have to find. So y of n and g of n are given, and we have to find the values of y of n square plus g of n square. Now it's a very interesting question, again based on the important properties that we discussed in the class. What are they? That if x of n will have the DFT pair as capital X of k, x of n has the DFT pair as capital X of k, then capital X of 0 is going to be summation of all the samples of x of n. It means it is going to be x of 0 plus x of 1 plus so on x of 7. Capital X of n by 2 will be summation minus 1 power n x of n, which is nothing but x of 0 minus x of 1 plus x of 2 minus x of 3 plus so on minus x of 7. These two are very, very important observations from the DFT. See, when I add these two, what am I going to have? When I add these two, if I take it as 1 and 2, first equation and the second equation, when I add these two, I will have x of 0 plus x of n by 2 is equal to 2 times it of x of 0 plus x of 2 and so on x of 6. And this is nothing but y of n, because y of n is the summation of the even samples. Okay, so what is x of 0? Capital X of 0 is 1 and capital X of n by 2, n is 8. In this question it's an n point DFT. So the value of n is equal to 8. So it's going to be n by 2, which is 4. So therefore you are talking about x of 4. X of 4 is going to be 17. Which implies that the value of y of n is going to be 9. When I do 1 minus 2, then it is x of 0 minus x of n by 2, which is going to be 2 times it of x of 1 plus x of 3 plus so on x of 7, which is nothing but 2 times it of g of n. And what is g of n? 2 times it of g of n, x of 0 minus x of n by 2. It is 1 minus 17, which is going to be minus 16. So which implies that the value of g of n is equal to minus 8. So y of n is 9 and g of n is minus 8. When you square them, it is 9 square plus 8 square, which is 81 plus 64. What is the value? 145. So the answer for this question is 145. This question is very beautifully framed because it is again using the same property, but it is asked in a very different way. Right? So this is the first part of the question 8. Now let us go for the second part of the question. Second part of the question is that for the above question, if DFT of x of n is computed using FFT, we know fast Fourier transform is the DFT with a different algorithm, because the conventional process of DFT is going to take a lot of time, a lot of computations. So in order to reduce the number of computations and to find the DFT, we use something called as a fast Fourier transform. And here we are using the fast Fourier transform. If alpha is the total number of multiplications and beta is the total number of additions, if alpha is the total number of complex multiplications and beta is the total number of complex additions, then what is the value of alpha plus beta? What we know is that the number of complex multiplications in the case of FFT, in the case of FFT, the number of complex additions, which is given as beta, is going to be n times it of log n to the base 2. And the value of alpha, which is complex additions, the total number of complex multiplications, alpha, which is nothing but total number of complex multiplications, is going to be n by 2 times it of log n to the base 2. We know n is equal to 8 in this question. The value of n is equal to 8. If that is the case, you're going to have 8 log 8 to the base 2, which is going to be 24. Because here you're going to have 2 power 3. So 3 comes outside, it's going to be 8 into 3, which is 24. If that is the case, here you're going to have the value which is 12. So the value of alpha plus beta, the value of alpha plus beta is equal to 36. The value of alpha plus beta is equal to 36. Right? So students, I will end this particular topic with a very simple suggestion about how to look to score in the GATE examination. In the GATE examination, you should always have the focus area subjects where you are targeting more to score. Definitely for any student, there will be strengths and weaknesses. Okay, you have to know which subjects are your strengths and which subjects are your weaknesses. So, and ensure that whatever strong areas are there, you practice sufficiently, and whatever weak areas are there, you can reduce the amount of practice, but you have to ensure that you are covering your notes. So that when you go into the examination, you first of all will try to cover the parts where you are strong at. And you have to give more amount of time in those areas where you are strong at. And wherever you are weaker, then you have to reduce the amount of time which you are giving. I will never say to leave any particular subject because of the fact that the easy questions or difficult questions is completely going to be subjective. No one can say from which subject easy questions are going to come and from which subject the difficult questions are going to come. You should be in a position to answer all the easy questions no matter where the questions are coming from. Therefore, you have to ensure that all the subjects are studied. And you should have a focus areas because of the fact that the amount of time that is left for you is less. So wherever you are strong at, you have to give more amount of time. Wherever you're not strong at, there you can reduce the amount of time so that you can score well in the GATE examination altogether. So with this session, I want to close this session. Hope this particular session is useful for you, and thank you. Wish you all the very best.